All right, this is section 7.1, finding square roots. And to start this section, we have an example of a purple square over here to the right, has an area of 324 square centimeters. We want to know what the side length of the square is. Well, because a square is in the parallelogram family, technically we're going to do base times height, but because it is a square, the base and height are the same. That's why they've used S for both the base and the height here. So, to solve this, I would think, okay, what number squared would give me 324? And so squaring is something we're going to have to review, obviously, if we're going to use square roots. And so one way to do this is to kind of guess and check. And of course, that's not the best way of doing it. But if you guess long enough, you'll find out that it's actually 18 times 18 that gives you 324. So then our side lengths would be 18 centimeters for each side of the square. And so when you multiply a number by itself, it's called squaring the number. So you would square that number. And so that's why we actually use the word square when we have an exponent of 2. The reason we say that exponent can be abbreviated as saying 4 squared instead of saying 4 to the power of 2. That's because 4 squared equals 16 actually gives you the area of a side length, or the area of a square that has a side length of 4. So if I'm squaring a number, I'm finding the area of that square. That's why we use that abbreviation. So if I square 18 up in that top example, that's how we get the 324. Well, the opposite, or the inverse of squaring a number, is square rooting. And that's what we're going to focus on today. But again, we've kind of got to review squares first. So the opposite of a squaring number is to take the square root of that number. So the square root symbol actually looks like kind of like a division symbol with a check mark on the left side of it. And so we would read that as the square root of 16. And so when you take the square root of a number, you're asking what number, when multiplied by itself, equals that given number. So if I square root 16, I have to think, okay, 4 squared is how I get 16. So the square root of 16 then is just 4. And so the square root symbol has 2 parts to it. It has the radical sign, which I've highlighted in blue here. And then it has the radicand. And the radicand is the number that's inside the square. It's what you're taking the square root of. So you would read this as the square root of 100. Now, one thing you may not know about square roots is that every positive number, and I'm going to come back to why that's so important, positive number, every positive number has a positive and a negative square root. So, for example, there's 2 ways that I can get 16. I can do 4 squared. 4 squared means 4 times 4, which is 16. Or I can do negative 4 squared. Negative 4 times negative 4 is also 16. So when I write the square root of 16, I can actually put 4 and negative 4. So to clarify this, the square root symbol, if it doesn't have anything in front of the sign, then you're just going to give the positive square root. If it has a negative sign in front of the square root, you're going to give the negative version of that square root. So the negative square root of 16 is negative 4. And if it has a positive and negative symbol, which you may not have seen that before, you're going to give both answers. So you could either say 4 and negative 4, or you could write the positive negative symbol with the 4 there. So every positive number has a positive square root and a negative square root. Of course, 0 is not a positive number, and so it only has 1 square root, which is 0. Now, we said every positive number has a positive and negative square root. And so the reason I emphasize on that is because when you multiply a number by itself, the product cannot be negative. So the square root of negative 16 does not exist. And so you may be thinking to yourself, well, hang on a second, wouldn't the square root of negative 16, why wouldn't that just be negative 4? Well, again, go back to what we did up here at the top. If you do negative 4 squared, you don't get negative 16, you get positive 16. There's actually no way that you can get a negative number by squaring it, because if the number is positive, a positive times a positive is a positive. If the number you're squaring is negative, a negative times a negative is a positive. So there's no way that you can square root a negative number because there's no answer to that. It doesn't exist. So that's why we have to put the negative outside the square root sign. So if we say the negative square root of 16, we're asking for negative 4. That's just the negative version of the square root of 16. But there is no answer. In fact, we would say that it's not real, is actually what we would say there. It's not negative 4. It's just not real. It does not exist. So let's look at these 4 examples here. It says find the square root or square roots. In example A, there's no positive or negative symbol in front of the square root, so we're just going to assume that one's the positive answer. So the positive version of the square root of 25, think to yourself, what number times itself or what number squared gives me 25, and that answer is 5. For example B, the negative square root of 1. Well, the square root of 1 is 1, so the negative square root of 1 would be negative 1. Now, you can square root fractions as well, and when you square root fractions, what you actually do is you're square rooting the numerator, and then you're square rooting the denominator separately on those fractions. So the negative square root of 9/16 is actually the same as negative square root of 9 over square root of 16. Now the square root of 9 is 3, and the square root of 16 is 4. So square rooting a fraction, you just square root the numerator and the denominator there, and we're going to get negative 3/4 for this one. And then the last example wants the positive and the negative square root, and so we're going to square root the top again. And I'm going to put the positive and negative symbol so you guys can see that. We're going to square root the top again to get 2. We're going to square root the bottom to get 5. So my answer is positive negative 2/5. Or I could write 2/5 and negative 2/5, but that's just extra writing when I have a symbol here, positive, negative, that gives me both. You can also square root decimals. And so when I square root a decimal, it's really just like square rooting any number. I'm thinking to myself, what number times itself would give me 2.25? That number is actually 1.5. And one thing to keep in mind is that 15 times 15 equals 225. So if I do 1.5 times 1.5, remember our rule when we are multiplying decimals, that however many decimal places our problem has, that's how many we'll have in our answer. So I have actually 2 decimal places, so I'll have 2 decimal places in my answer. So 1.5 times 1.5 does give me 2.25. And then, for example F, 31.36. Now we actually have a button on our calculators. If you have a scientific calculator, or most 4-function calculators actually have the square root button as well. You can just type these in and it'll do the work for you. And so when you type this into your calculator, you'll get the square root of 331.36 is 5.6. Now, that leads us to a big vocab word that we have in this chapter here, and that's perfect squares. And so a perfect square is a number with integers as its square roots. The square root of any non-perfect square is irrational. And so what that means is that 99% of the time, when you square root a number, you're going to get a long, non-terminating, non-repeating decimal like pi. That's called an irrational number. 99% of the time, when you square root a number, you get this number. But when you square root a perfect square, you're going to get a nice answer, an integer answer. So if we can actually make a list of perfect squares. The list is infinite, but we'll just list out the first few here. 1 squared is 1. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. So when I square root any of these numbers that I've written in blue here, I'm going to get a nice answer. That's why we call these numbers perfect squares. Okay, so again, 5 is not a perfect square. 6 is not a perfect square. It's 25. It's 36. These are your perfect squares. I actually have these numbers on the clock in my room for you to look at. It goes all the way up to 12 squared, which is 144. But that list goes on forever. So I could even go to 23 squared, 24 squared, and 25 squared. So 23 squared is 529. So 529 is a perfect square. 24 squared is 576, which is a perfect square. And then 25 squared is 625. And again, this list just goes on forever. These are all called perfect squares, and they're perfect because when I square root them, I get nice, perfect, if you will, answers. But when I square root any other number, like a nice number is the number 50, for example. If I square root 50, I'm going to get a terrible number, though. It'll be irrational because 50 is not a perfect square. As nice as 50 is not perfect. 49 is perfect. The square root of 49 would give me 7. So the square root of 50 is going to give me 7.1, maybe, 7.0 something, but it's not going to give me a perfect answer. So these numbers down here in this next example, these are perfect squares. It wants us to find the 2 square roots of each perfect square. So that would be the positive and the negative version. So the positive and negative version of the square root of 36 is positive negative 6. The square root of 4 is 2, so positive negative 2. And the square root of 121 is positive and negative 11. If I would have asked you to do the positive or the square root of 120, you'd get a terrible number. 24, terrible, right? These aren't perfect squares. It's only the perfect squares like 36, 4, and 121 that give us nice answers. So as I mentioned earlier, squaring and square rooting positive numbers are inverses, just like multiplying and dividing are inverses. In fact, taking the square root of a number is the same as raising it to the 1/2 power, which you probably did not know. So if I said, what is the square root of 64? That's actually the same as saying, what's 64 to the 1/2 power? And so one thing that kind of is hidden in the square root symbol is the fact that when you're square rooting a number, there's a hidden 2 up here. And that's why we've talked about cubed roots before, actually in our volume chapter when we were finding the cube root in order to find the radius of a sphere. And when you cube root, that's why there's a little 3 up here in the corner. So a square root technically has a 2 up there, but we don't write it. It's implied that it's a square root if you don't have a number there. And so the reason I'm telling you this is because when we solve problems involving square roots, you treat the square root as it's a power. So when we use the order of operations, please excuse my dear Aunt Sally, we're going to do the square roots where we would normally do the exponents, because you can treat a square root, like I mentioned before, as an exponent. So these next examples are going to have us actually evaluate these expressions using the order of operations, parentheses, exponents, multiply, divide, add, and subtract, or PEMDAS. And so when we solve them, like I said, we treat the square root symbols like they're exponents. So here we have 3 operations we have going on here. We've got multiplying the 5 to the square root of 36. We have in itself the square root of 36. And then we have adding. So multiplying a square root, which is an exponent, and adding. So we have to do the square root first because it comes first in order of operations. So the square root of 36 is 6. And so I'm going to do 5 times 6. Plus 7. Of course, 5 times 6 is 30, and 30 plus 7 is 37. Make sure you're showing your work, and you can think of it as funneling your work down, right? We've done problems like these in the past where we've funneled our work down, so make sure you show all your steps as you're solving these problems. In example B, I have to square root 18 halves first. Now, 18 and 2, neither one of those are perfect squares, so I'm going to get terrible answers. Remember I said when you square root a fraction, you treat it like you're square rooting the numerator and then square rooting the denominator, which is going to give us terrible answers. So one thing you'll want to do beforehand, if you can, is reduce the fraction. And so 18 divided by 2, it's almost as if we're treating this like it's got a set of parentheses inside of it. Like, look at what's inside the square root first. 18 divided by 2 is 9, so 1/4 plus the square root of 9. And now that we've simplified that fraction, we're going to get a lot nicer answer because the square root of 9 is just 3. And 1/4 plus 3 is 3 1/4. In example C, it says the square root of 81 squared minus 5. Now remember, square roots and squares are inverses. So if I square root 81, I'll get 9. And then if I turn around and square 9, whoops, if I square 9, I'm going to get 81. And that's because, again, they're inverses, so I can scratch them out. They basically undo each other. So I'm just doing 81 minus 5, and 81 minus 5 is 76. Example D, here we have another example of a problem where we want to simplify the fraction before we try to square root it, because the square root of 28 and the square root of 7, neither one of those are perfect squares. So we're going to get a terrible, irrational answer. We don't want that, because 28 divided by 7 is just 4. So if you can reduce these fractions first, please do that. It saves you a ton of effort. The square root of 4 is 2, because 4 is a perfect square. So we're going to get a nice answer. And then 2 plus 2.4 is 4.4. All right, so let's answer the question of why it's called square root, right? Like, why do they use that word square root? And that's because, as I mentioned earlier, when you square a number, you're finding the area of that square. So if I said, hey, what is 5 squared, and you said it was 25, you've just told me the area of a 5 by 5 square. So square root is the opposite of that, and the root of a square is the side length of that square. So if I want to know what the side length of this green square is, I just square root 361, because I want to find what the root or what the side of that square is. And the square root of 361, believe it or not, that is a perfect square. You're going to get 19. So each side of the square is 19 miles. And then in example B here, we've got another fraction. So I'm going to square root 4/9. And again, this is a fraction that does not reduce. So I'm going to square root the top number. I'm going to square root the bottom number. And the square root of 4/9 is 2/3. And I can double check that, because 2/3 times 2/3 equals 4/9. So we know it's 2/3 feet for this one, 19 miles for example A. And then we can do a similar thing down here with these circles when it asks us to find the radius. Now that's because when you find the area of a circle, the area formula that you probably remember is pi r squared. So the formula in itself has a square in it. And so these answers are both written in terms of pi. And so if 36 pi is the area, I can plug that in for A in our formula and find out what R is. Both sides of the equation have a pi symbol, so I can cancel that out by dividing pi on both sides. And that leaves me with 36 equals R squared. Of course, we just said square rooting is the inverse of squaring, so to solve this equation, I square root both sides, and the radius has to be 6. In the green circle over here, again, the formula is A equals pi r squared. So when it says the area is pi, well, then I just plug pi in for A. And so I can eliminate the pi on both sides, because I can divide both sides by pi. When you do that, that doesn't leave 0. That actually just leaves you with the number 1. Pi divided by pi is 1. Any number divided by itself is 1. So if 1 equals r squared, square rooting both sides would tell you that the radius of the square is 1. So I'm doing a lot of work here just to show you why we get the answer of 1 yard. I didn't label this last one. It should be 6 inches. So 6 inches is the radius for that one. 1 yard is the radius for our green circle. On the topic of circles, this one takes me back several chapters, takes us back several chapters when we did our area and surface area and volume chapter. And so this one says the area of a crop circle is 45,216 square feet. What is the circumference of the crop circle? Well, the area formula is, like I said before, A equals pi r squared. The circumference formula is C equals pi d. So in order to find the circumference of the circle, I'm going to have to work backwards to find out what the radius of the circle is, and then therefore the diameter of the circle. And so I'm going to plug 45,216 in for the area of our circle. That's what it says the area is. So when I divide by pi on both sides, notice how there's not a pi symbol. This answer was not written in terms of pi. There was no pi symbol there, so I do have to divide by 3.14. When I do, I get 14,400 equals pi r squared, or sorry, equals r squared because I got rid of the pi. And then now I'm going to square root both sides. And so when you square root both sides, 14,400 is actually a perfect square. We get 120 for the radius of that crop circle. So the radius is 120, and that would be feet. So in order to find the circumference, which remember the circumference goes around the circle, not the space inside, but the distance around it if I were to do a lap around it. And I need the diameter for that. And so if the radius is 120, that makes the diameter 240. And so I can multiply 240 by pi to figure out what the circumference is. And that is 753.6. And that's going to be just feet because it's circumference. And so I'm using 3.14, obviously, not the pi button, for pi there. One last story problem with square roots. It says you're putting a wire fence around your square garden, so it might be beneficial to have it just kind of imagine our square garden here. You're putting a wire fence around it. The area of your garden is 484. The wire costs $3.50 per square foot. How much will a fence cost you? And so I need to square root in order to find the root or the side length of my square. And so the square root of 484 is 22. And so each side of the square is 22 feet. Now, if I'm putting a wire fence around my square, I need the perimeter. And because all four sides are equal, I can just multiply this number by 4 to get 88. So I need 88 feet of fencing. And normally I'd be done because I have my perimeter, but it actually wants me to find the cost. So then if each foot of wire is $3.50, we're going to times that by 88 to figure out what that price would be. And so when you do that, you get 308, and our answer would be in dollars. So again, you probably have solved problems like this before. Maybe you just didn't know you were using a square root symbol when you were finding the side length of a square. And that's why we call it the square root, because that's the root or the side of the square.